My name is Dr. Costis Papageorgakis, and I'm from the physics department at Queen Mary University of London. String theory provides the mathematical framework for describing in a unified way all the phenomena that we see in the universe around us. So string theory departs from the conventional notion that the smallest fundamental bits of nature are particle-like. Instead, it assumes that if you could zoom in these subatomic particles very, very closely in, you'd find some either open or closed vibrating string. For example, open vibrating strings could describe phenomena having to do with light, and closed vibrating strings phenomena having to do with gravity. Because the strings are very, very small, there is no hope for currently directly experimentally detecting string theory. However, the mathematics of string theory, which are beautiful and very consistent, gives us faith that we are down the right track with them. We mentioned that mathematical consistency is one of the key aspects of string theory. And it turns out that in order for string theory to be mathematically consistent, you need, instead of 3 + 1 dimensions of space and time, 9 + 1 dimensions of space and time. So a question that you can naturally ask is, what happened to the other extra 6 spatial dimensions? One way to circumvent this problem is to assume that these extra dimensions are very small. In fact, they're curled up into tiny shapes known as Calabi-Yau manifolds, named after the name of the mathematicians that discovered them. In the beginning, it was hoped that there would be a unique mathematical framework associated with string theory that would describe the world that we see around us. That gave rise to hopes of being able to identify a theory of everything. Unfortunately, that turned out not to be the case for various reasons. The first reason is that instead of only one mathematically consistent string theory, one can construct 5 string theories. These 5 string theories can be related to each other by transformations, mathematical transformations known as dualities. Moreover, when you roll up the extra 6 dimensions to recover a 3 + 1 dimensional universe, such as our own, you can end up with widely different physics depending on what kind of Calabi-Yau manifold you choose. And all of them are mathematically equivalent. So string theory is not a theory like quantum field theory. It is a framework that can ultimately describe physics like the ones that we see in our universe, but also allows for many other possibilities. So up to the mid-90s, the fact that there are 5 distinct string theories was a source of great puzzlement for the community. Around that time, it was however realized that there exists an 11-dimensional framework which has the 5 string theories as its limits. M-theory is not a theory of strings, but it's a theory that is known to contain membranes and higher dimensional objects, in particular 5 branes, where the brain comes from a truncation of the word membrane. These are objects which we cannot perceive with our senses, but mathematically we can generalize the notion of a membrane. So M-theory could stand for mystery theory, mother theory, or membrane theory. So why isn't everybody working on M-theory? The answer is that M-theory is hard. To think of an analogy, M-theory is a big room where all the lights are turned off, but there are several spotlights that shine on certain corners of the room. One could try and perform an excursion from the lit-up corners that we understand and see into the darkness. So trying to understand the full of M-theory is hard. One might try to understand some of the objects that appear in M-theory, such as M2 branes, membranes, or M5 branes. M2 branes and M5 branes were not understood for many, many years after the introduction of M-theory. However, in 2008, there was interesting work, part of which was based on my results, that made the physics of M2 branes transparent. So in recent years, there's been a kind of paradigm shift where instead of trying to understand the full theory of M5 branes, we're trying to understand a chunk of the theory. And there have been mathematical advances which allow us to have full control of these chunks. So again, using the diagram analogy, think of the darkness and the corners, but also light beams that cut across the darkness and give access to an area that we didn't know before. And hopefully, as time goes by, we'll be able to get more of these beams cutting across the darkness to get a fully lit picture.